Couple of slides on best practices when working on an HPC cluster. So let's start with best practices for computing. I already mentioned several times that when you log into a cluster, you find yourself on a login node, and these login nodes should not be used for anything CPU intensive, memory intensive, etc. Because if you start doing anything large on a login node, then we'll notice that immediately, and other users on the cluster who are logged into the login node, they will also notice that because the cluster is going to be very slow. Everything will slow down for them. So please don't run anything intensive on a login node. Please do that by submitting a job to a compute node. Only request resources that you think you might need. So that especially applies to memory and runtime. If you ask for too much resources, then your job will end up waiting a very long time before it can get started. And to find out how much memory you're going to need, please use the slurm commands. So the commands sact, sf, to find memory usage for a completed code. Please study scaling of your code. Start with small problems, increase the problem size, and try to understand how this scaling affects the memory usage and the runtime. If you're running a parallel code, run a problem on one processor, on two processors, let's say 4, 8, 16, and so on, and try to understand how that changes the runtime. And usually all codes, all complex codes, have the maximum number of cores they can run on efficiently. And if you try to run this code on even more cores, then you will find out that you don't get any speed up from that. So usually the parallel efficiency plateaus at some critical number of cores, and beyond that, you just don't get any speed up. And there are many reasons for that. So there are lots of bottlenecks, communication bottlenecks, I/O bottlenecks, etc., etc. And you have to be aware of these things. For faster turnaround, if applicable, request whole nodes as opposed to specifying the number of cores. And also, if possible, specify shorter runtimes. If you can break a long job into smaller jobs, that will complete faster because it is much easier for the scheduler to fit short jobs onto the cluster. When you compile a code, make sure you always use optimization flags. So the sweet spot is usually -02, but you can also use -03 if that works for you and does not break a code. And a code that was compiled with these optimization flags will typically run much faster, a factor of 10, perhaps 20 faster than a not optimized code. Also, be aware of what kind of language you're using. I already mentioned at the very beginning of this course that compile languages are usually much faster than scripting languages. If you're writing a new code, then please consider using a compile language like Fortran, C, C++, Chapel, Julia, but not a scripting language. So scripting languages themselves will be slow unless you spend a lot of time in a precompiled optimized library like NumPy, SciPy, etc. Next, let's take a look at best practices for file systems. Clusters have parallel file systems that were designed for storing a small number of large files. They're designed for working with very large data streams. So a small number of large files, but not the other way around. If you put a lot of small files, let's say tens of thousands or millions of small files onto the file system, that will actually make that file system very slow, not just for you, but for everybody else using the cluster. And this is the reason why we actually have a quota, not just on the total disk space, but also on the number of files. If your code outputs a lot of files, consider changing the code so that it outputs fewer larger files, or use the tar archiving command or the dar archiving command. Do not store large data as ASCII, as text-based output. This is kind of obvious, but unfortunately still a lot of people do that. And ASCII output is just not efficient. So anything beyond a few megabytes, especially if you're writing gigabytes and gigabytes of data, please do not write it as text, as ASCII, because this is just not efficient in terms of disk space usage and also I/O bandwidth. Please write this data as binary, especially if you're writing, let's say, multidimensional arrays. There are actually scientific libraries like NetCDF and HDF5 that were designed specifically for writing large multidimensional arrays. And you can actually write these arrays in parallel. And you can also compress them inside the library. So I would say, please don't use ASCII, use binary. And if you can, use one of the libraries that were designed specifically for fast read and write, things like NetCDF, HDF5, and a few others. Also remember to use the right file system. The home directory, the default directory you find yourself in when you log into a cluster, is actually not meant for storing large files. It's not a high-performing file system. For that, please use Scratch. So if your code is writing a lot of data, then please do that in the Scratch file system. If searching inside a file, you might want to read this file first. And the reason for this is because search will read lots of small chunks, and this is just not efficient with a parallel file system. So you might want to read the entire file first, load it into memory, and then search this file in memory. And that will be much faster than searching inside the file on the disk. Have a backup plan. This is kind of obvious, but some of our file systems are not backed up. For example, Scratch is not backed up. And if there is a problem with the disk, you can actually lose all your data. So make sure you copy all simulation data somewhere else. Regularly clean up your space in Scratch and Project, because these file systems have quotas. And as I mentioned with Scratch, there's actually a very large quota. I think it's 20 terabytes or something similar. But that does not mean that everybody can just put 20 terabytes of data. We just don't have enough space for everybody. If you have some data that is sitting on Scratch for a while, please consider moving into another file system. And remember that Scratch has a purge policy. We're going to delete files that are older than usually 6 weeks. In summary, this page shows some of the resources, documentation. Our email for support is support@computecanada.ca, and those emails will go into the ticketing system. When you send this email to support, please make sure to provide as much detail as possible. Please copy and paste the exact error message. Tell us the Slurm parameters you used submitting your job. We need to be able to recreate your problem so that we can understand it and solve this problem. So please try to provide as much detail as possible from the very beginning. Official documentation for Compute Canada is docs.computecanada.ca/wiki. And finally, please get to know your local support. We have support staff in most WestGrid and most Compute Canada institutions. So there's usually a local HPC analyst, and please get to know them and they'll be happy to help you with any problems.